So greetings everyone. So my name is Vinil, and the problem statement our team Lateral Avengers is dealing with is that we have to develop a software application for the analysis of DWRL data and raise alarms for the respective anonymous values and faulty DWRLs, etc. So let's deep dive into the problem statement so that we can know more about it, and later we can talk about the proposed solution. The organization which provided this problem statement was Ministry of Jal Shakti, and it is regarding the water resource management. So the description mentioned here is that Central Groundwater Board is in process of installing digital water level recorders, which in short called as DWRLs, across the country, and CWB will be monitoring 14,000 DWRLs by 2026, which will generate high frequency water level measurements. Each DWRL will record 4 groundwater level data per day, generating 1460 measurements per year. Analyzing all the 14,000 wells will be an enormous task. Accordingly, a software application is proposed to analyze and flag anonymous data. Input to the application will be high frequency water level data collected through the telemetry systems. The application should be able to identify the DWRLs recording no data, abnormal data, or DWRLs with low battery. The application will raise alarms and send messages to the concerned officer and vendors to initiate immediate action. So from this we can understand that the central government is planning to monitor the water levels of borewells across the country. There will be sensors that will be sending the water levels of those borewells respectively, and every day each sensor will send 4 data values, and if we can calculate for 14,000 sensors, per year this much of data will be generated from the sensors. So it will be a huge task for the government to analyze all of them manually. So they want an automated software which detects the abnormal data, or if there is no data that is going to be received from the sensor, and if there is any low battery issues with the DWRLs. So all those kinds of issues, they need to be addressed in a software. So we are going to develop a software that collects all this data and analyze them, and if there are any issues with those DWRLs, they are going to send a message to the concerned officer or vendor to take an immediate action. So that is all the problem statement is about, and let's deep dive into our solution. So that's all about the problem statement. So now the proposed solution is that we don't have to collect the data from the sensors. They will be available in a telemetry. They will be going to transfer the data through a telemetry, and those will be stored in a centralized database. So we are going to retrieve those data values from the database, and we have to analyze them using our software which we are going to develop. So we have developed an AML model using the long short-term memory model, so to detect the anomalies. So if there is any issue that is encountered in the data we have fetched from the database, that is no data or abnormal data or low battery, so it will be tallied out with the previous historical data, and it will trigger the real-time notifications to those vendors. Going to develop the role-based access and user management also. There are different kinds of users that are going to be interact with that software application. So role-based access is a good to go feature, and security and feedback regarding we have a centralized database, right, and we have to fetch the data without any manipulations or any kind of issues. So we have to create a secure environment to fetch the data. Regarding the system monitoring and maintenance, since it is an AML model, it is not going to be perfect from the very first day itself. We have to constantly monitor the system performance on a regular basis, and we have to train the model with additional data sets, or correcting the any data sets that have any anomalous values, and if they have sent any unusual notifications, we have to train the model accordingly. So from the next time onwards, it will send accurate notifications to the vendors. So regarding the technical approach, for the front end we are going to use React, which is more than a framework which is going to be used for the every application, almost in every platform. So it is used so that we can have a user friendly interface. And so regarding the mobile application, we are going to use Flutter for the front end. As far as the back end is concerned, we are going to use Node.js for those API management and all those things for the back end, and we are going to use MongoDB for storing the water level and telemetry data. For processing and all those things, we have to use a fast service, that is AWS Lambda, for efficient real-time alerts. Regarding the cloud infrastructure that is going to accommodate all those things, we are going to use AWS service, and we are going to use the AWS SageMaker service for training and deploying those machine learning models for efficient use of those things, and AWS S3 for scalable cloud storage. And regarding the services like sending notifications to the vendors and all those things, we are going to use AWS SNS, I mean simple notification service. And machine learning models, we are going to use TensorFlow for training those models with the predefined datasets. So the process flow goes like this. The DWRL sensors will send the data, and data collection and transportation will go through these three layers. DWRL sensors will send the data to the database or telemetry, whatever we call. So from that, the deployed ML model will fetch those data from the database and check if there are any anomalies in the water levels and battery levels and all those things. And if there is any no data or abnormal data, or what if the battery level is below the threshold, if any such kind of issues are found, it will be sending alert to the officers. If there are no issues, no issues are not found, it will be sending those data points to the database, which will be stored in successfully, and that data will be again used to train the model also. So like this the process flows go. So regarding the feasibility and viability, for the technical approach, we are going to use React Flutter, as we discussed in above, for ensuring reliable data collection, storage, and analysis. And for the operational, we are going to use AWS infrastructure for to managing all those data points that we are going to receive from the DWRLs. And regarding the financial feasibility, we have to initially invest in a cloud, that is AWS or any other service. And for the ML model, we are going to collect a huge data sets from the already existing DWRLs for training those ML models. And for the viability scalability, we are going to use MongoDB. We can in the real time we can increase the volumes and all those things. For the reliability, we are going to use AWS S3, SageMaker, and Lambda, and all those things for robust performance. As far as the challenges encountered during solving this problem statement, regarding the data quality, we are handling missing data and inaccurate data values, so that became a problem. Regarding the model accuracy, sometimes even if the DWRL is producing the correct data, it is going to send the false alarms. And regarding the communication latency, achieving real-time data transmission with minimum delays is became a problem. So the strategies we are going to use for addressing those challenges was data pre-processing. So we have to classify the missing and inaccurate values as anomalies, so that for those values it is going to send a message directly. For the model validation, we have to continuously train the AML model so that it will produce correct outputs. So regarding the data latency, we are going to use multiple data protocols so that the data will be transferred with minimum delays. Regarding the security challenges, we are going to implement encryption and conducting regular security audits so that the data is not going to be misused anywhere. Regarding the impact and benefits, it's going to provide a sustainable resource management system for the long-term groundwater conservation. It will also provide improved data accuracy, so continuously monitoring leads to the more reliable water level data. Regarding the government policy support, it can help a government to make separate policies for each region which is having different water levels. So which is having low water levels, the government can implement stricter policies for the water usage and all those things. So if there are any excess water levels, so that the government can provide some sort of benefits for those kind of people. Getting the public awareness also, it will create benefit for the people, so that people can know what kind of water levels they are having in their region, so that they can effectively use those water resources. Regarding the environmental protection also, it will taking timely actions can reduce the risks of over extraction and environmental degradation. The benefits of the solution, as we have discussed before, it is going to monitor the data in real time, and it will also provide early anomaly detection features, so that it will if there are any flags such as low battery or all those kind of things, it will send notifications accordingly, so that the anomalies can be prevented. And so another feature is efficient resource allocation, so that it will send data to the officers only when there is a need to check the DWRL, so that the it will reduce the manpower and as well as the efforts for those unusual maintenance also. And regarding the scalable infrastructure, we are going to use a cloud-based architecture for if there are any kind of new sensor that is going to be installed in the future, so that we can scale out the infrastructure also. And last but not least, it will also help nation to meet its water conservation goals and regulations. Regarding the research and references, we have taken the data from the government website itself, and for the anomaly and machine learning, we have used these respective websites. For the reference, for the React documentation and GitHub, we have used these developers websites, and for the AWS, we have used the documentation from the AWS itself. So let's have a quick demo about the prototype, and so that we can have a better idea about the proposed solution. Regarding the demo, we have used Python for the backend and React for the front end. So we are going to now start the backend server, so that we can have that ML model running. Now the ML model is running in the backend successfully. So let's start the front end also. So this is going to be the website that we have developed, and first let's add some sensor data. Actually, these sensor data will be going to be already there in the database itself, because the sensors are going to be automatically send the data to the telemetry via telemetry. So for the this demo purpose, we are going to add the sensor data to the database, and we are going to send those data for the prediction. So we are now going to send some 4 to 5 values for the prediction. Now we have 4 data values, and we are going to set an additional data point. You can see from the prediction results that the Vijayawada data which we have inserted initially was showing normal, because the water level and battery level is going to be completely alright. And for the Hyderabad and Guntur, we have seen that the battery anomaly is there, because the battery is below the threshold. We have set we have set a threshold of 20 for the battery level. So since it is below that 20 level, so it is showing the battery anomaly. And for the Guntur, the battery level is good 27, but the water level is below the threshold 11, so there is a water anomaly there. And for the Khammam, it is having both, that the water level is below the threshold and as well as the battery level is below the threshold. So that's why it is showing water anomaly and battery anomaly. So for the demo purpose, we have inserted another data value from the Vijayawada itself without having any water value or battery value. So that's why it is showing sensor data anomaly. That means there is no incoming data from the sensor. So it will send notifications for all those these 4 cases, and for the normal case, it will send those data to the database. So this is all about the problem statement and the proposed solution. Thank you for watching this video.